All right. Let's see. Thank you everybody for tuning in to the Corundum developer meeting today. Let's see here. So I don't have all that much to talk about, just the announcements, then briefly talking about some product ideas, just in case people want to dig into something, and then status updates. All right. So announcements. Unless something changes, the next Corundum developer meeting will be on September the 11th, and the next Switch development meeting will be on September 4th. There was some talk about maybe adjusting the Switch one. I'll make a post about that or something after speaking with Carlos later this week. All right, so like last week, I put up some product ideas. So I think there were recommendations for a couple of additional ones. So the idea with these product ideas is that if you're interested in getting involved in the project, but you're not really sure, what to do, there's a few ideas here that are potentially somewhat closed-ended things to work on. Well, some are more closed-ended, some are more open-ended. But anyway, I'm just going to say a couple of words about each of these just really quick here. So one idea is oversampled 1000 base X on a 10G base R transceiver. In some cases, it's not really feasible to reconfigure the transceivers to 1.25 gigabits per second for various reasons. So the question is it possible to just take a transceiver that's configured for operation at 10G and use it at 1 gig, or potentially other related line rates like 2.5 or 5 gig? Could be an interesting project for somebody to look into. I think on the transmit side, it might work pretty well. On the receive side, there's some question as to whether the transceivers are going to be well behaved. So got to do a little bit of testing to make sure it'll work, and then some implementation. So that's one idea. Another potential project is an open source 40 gig Mac plus PCS. I've had a couple people ask about 40 gig support. I know there is some open source code floating around for 40 gig Mac, 40 gig PCS. It's possible that if we take all that code and put it together, we'll have something that works. It's possible that there's still some pieces missing. So possible that maybe we can just use that code as a reference to make something new from scratch, but that could be something interesting for somebody to chip away at. 40G is naturally going to be a little bit more complicated than 10G because there's 4 lanes, but it is going to be significantly less complicated than 100 gig, especially because 100 gig requires RSPEC and 40 gig doesn't require that. So that could be an interesting project. Then kind of along those lines, it would be nice to make wrapper modules that kind of integrate all of these different Macs and all the different line rate support into a single module that can, runtime switch between those. Right now we have wrappers for 10 gig / 25 gig and for 100 gig, but it would be possible, I think, without too much difficulty to roll those into the same wrapper. And then if we have 40 gig Mac, we can potentially add support for that, and the gigabit support, we can roll that in there as well. So that could be an interesting project to chip away at it as well. Next up, the RISC-V management core. The idea behind this is to offload all of the board-specific interfacing, such as reading MAC addresses and interfacing with transceiver modules, and potentially even some stuff related to firmware updates and a few other things, and putting that on the FPGA itself in a low power RISC-V management processor. This has been something that I've had on the back burner for a while. It's something that I want to do, but I haven't had time to really sink my teeth into it. So if there's somebody who would like to get involved and knows a few things about RISC-V, that could be an interesting project to take a look at. And this means that it'll be a lot easier to get both, the main Corundum device driver as well as out-of-tree drivers like the DPDK driver or whatever to support a lot of the same management features because it'll all be through the same API to the management core as opposed to a bunch of board-specific stuff. Let's see. So next up, open source FTDI-based JTAG adapter with Alveo connectors. So anybody that's got like a U50 or an SN1022 is probably aware of the weird JTAG connectors that Xilinx is using on some of their boards. And they sell a rather expensive dongle for interfacing with that. So the idea is well, could we spin a little board with a couple of these oddball connectors on there, along with an FTDI chip, and basically have a little all-in-one JTAG adapter that we can plug into mainly the U50 and the SN1022, but we can also just put a normal JTAG header on there as well, and you can use it with other boards. Shouldn't cost all that much in terms of components, but for somebody that wants to spend a few minutes laying out a board, that could be an interesting little project. Let's see, another thing, an improved transmit scheduler in Corundum right now is just round robin, but replacing that with something that can do weighted fair queuing, rate limiting, other stuff, could be an interesting project. Although that might be a research project in and of itself to implement a more flexible scheduler. Another thing that I've had on the back burner, a couple of people have asked about, is SRIOV support, where you can have multiple PCIe virtual functions talking to the same NIC. And this, I think, will require making some modifications to some of the PCI Express components and DMA components and whatnot. But it could be a rather useful base for a couple of these other features. So multi-head support, the idea is to have multiple PCI Express interfaces and or AXI interfaces all connected to the same core NIC logic. So, for example, you might have a 250 SoC from Bitware that has a relatively large Zinc chip that has both 16 lanes of PCI Express and the integrated hard ARM cores. So with the multi-head setup, you could have both of these connected to the NIC at the same time, and all of the sharing and whatnot would work appropriately. So the idea is to build this on top of SRIOV so that effectively the internal AXI interfaces or the additional PCI Express interfaces would look like additional virtual functions. So they'd be managed the same way in terms of the configuration logic on the physical function that kind of owns everything, can assign resources and configure packet forwarding and whatnot appropriately to even the AXI interfaces that would be connected to the Zinc or whatever. So that could potentially be a pretty interesting thing to have. And then also improved application section support for SoC devices, where you might want to have some of the additional AXI interfaces and other connections that some of the SoC type devices provide available in the application section directly. I know there could be things like cache coherent interfaces and whatnot that aren't really present on other devices, but it would make sense to have kind of a pass-through just in case those are needed from the application perspective. So that's a few project ideas. If those sound interesting, contact me or hop on Zulip or whatever, and we can certainly discuss it. All right, so moving on to status updates. So a few things that I've been working on here. We've got Mac control and PFC stuff that I've been chipping away at. As part of that, I've made some updates to some of the libraries that Corundum uses, AXI Stream or Ethernet. I've made another handful of minor changes to Corundum itself, and then a couple of future-looking things. I've been thinking about how to improve some of the timestamp handling in Corundum to improve resource utilization. And then also, the folks at Arista sent me one of their new FPGA-based switches to start taking a look at, potentially as a base for the switch project. So let's get into this one at a time here. All right, so the Mac control and PFC/pause frame support. Gone over this a couple of times. Not much has happened over the past couple of weeks here because I've been working on some supporting components that are going to go into the port level data path as well. But the idea here with Mac control and PFC pause frames is to provide hardware flow control. So it's one thing to actually implement sending and receiving of these frames. It's another thing to actually connect them up to the data path such that traffic classes are actually paused when we receive a control frame, and we can generate control frames based on the occupancy of the received queues. So there's a few things that need to be done in order for this to work correctly. Yeah, so not much else to say on this. Hopefully, over the next couple of weeks, I'll actually have this finally squared away, along with a couple other things I've been working on. More details on that in a couple slides here. All right, so updates to libraries. The AXI Stream FIFOs. Last time I was talking about a couple of features that I implemented, and one of them I was working on, including which was the pseudo-elastic buffer support. So I finally finished that up, and the upshot of that is it means that with that implemented, I can shrink the async FIFOs in Corundum on all the transmit and receive paths. And that saves some logic resources and allows blockgrams to be used in the synchronous FIFOs or application logic or whatever. And also for the Ethernet Max, I added TX and RX enable inputs so that you can basically turn off receive if there isn't a link, to make sure you're not getting any weird stuff coming out of the Mac. So I think the first change has been pulled into Corundum. The second change is going to be pulled into Corundum soon. So in terms of the first change for the pseudo-elastic buffers, I've gone ahead and updated Corundum to use basically 32 entry FIFOs for both RX and TX. So that ends up being, I think, like 256 or 512 bytes for 10G, 25G, and I think 2 KB for 100G. And these sit in LUT-RAM instead of blockram. So this frees up blockram for use in the synchronous FIFOs or in other components. And interestingly, it seems to improve the time performance on 25G designs, probably because there's a lot less placement restrictions on where the distributed RAM memory elements can go versus the blockrams. So I think things can get packed a little bit better for all the Macs. Things just seem to close timing more reliably after this change. I've also added support for a couple of additional things. I added support for the an older board from Bitware, the XUSP3S, which is kind of a precursor to the XUP-P3R, but with a Vertex Ultrascale instead of Ultrascale Plus part. I actually picked up a stack of these. They could potentially be, they're probably going to be more useful maybe as a 25 gig switch, because they have, 16 ports of 25 gig versus a NIC, because they only support 8-lane interfaces to PCI Express. Although it does have 2 bifurcated by 8, so I don't know. Anyway, that's now in the mainline repo, and for all of the board-specific stuff, it's basically the same as the XUP-P3R, so it doesn't have to add much in terms of additional driver code. And then on the Silicon board, the FB4 CGG3, I added the DRAM support for that. So both the 2 on-card banks of DRAM as well as the 2 SODIMM slots. That's all operational now. I also made a modification of the driver to drop short Ethernet frames. So if there's an Ethernet frame that's smaller than an Ethernet header, obviously that's not really a valid frame. The driver now drops that. It seems to be occasionally when you don't have a cable plugged in to the FPGA, under certain circumstances, it will generate very short frames. I'm not sure exactly what the cause is behind that, but this was causing some issues with the with Linux, because there's a bug. There's a bug in the receive path in the kernel where it attempts to extract the Ethernet header, realizes it doesn't have enough bytes, so it fails. It prints out a message saying, what is it, cropping impossible SKB, and then it returns null. But then subsequently, in the same bit of kernel code, it then dereferences that null and then crashes. So a bit of a failure in defensive programming there. So it's unclear if that bug is going to be fixed in the kernel at any point in the near future, but it's definitely present in several kernel releases. So it makes sense just to add this check to the driver to make sure that we're not causing any crashes. So that's in my development repo as well. So the next step after this is to get the basically an overhaul of the port control registers to get that squared away, and that's going to bring in support for the pause frames as well as the Mac TX and RX enable control stuff. So with that set up, the driver will be able to, turn off receive for all of the ports that, we're not expecting to be getting traffic from. Yeah, so I think that's about it in terms of the updates to Corundum for now. Hopefully, the next week or two, I'll get this this last piece squared away here. Now moving on to the potential timestamp handling improvements. So one thing with high resolution time of day timestamps like the 96-bit timestamp for PTP is that, well, they're large. And also the most significant portion of it is effectively constant when you're operating at high data rates, because you're not going to be holding on to packets for very long, right? So the 96-bit timestamp, it's 48-bit seconds, and then basically 32.16 fixed point value for nanoseconds. And yeah, right, that 48-bit seconds field, it only changes once per second. So running that all over the device just ends up being a major waste of logic resources. Because if there's a way to, say, regenerate those seconds portion somewhere else, only where you actually need it, you might be able to save a lot of logic resources with, all the FIFO logic and all of the actual, timestamp capture components. So the question is it possible to do this? And along those lines, you'll have to handle things like, timestamp rollover, whenever that seconds field does actually increment, then that has to be handled correctly. There's potentially going to be multiple clock domain crossings involved, multiple clocks involved, and potentially long wires. This might need to be sent a long distance across a device. But if we're talking about something that only changes once per second, seems like it should be reasonable to come up with an improvement for this. So kind of the plan that I've been mulling over here is something like this. We'll take the timestamps, we'll split them into two portions with a small amount of overlap. So for example, you could have your 48-bit fine timestamp in fractional nanoseconds, and then maybe 48 plus 2 bits for the coarse portions. We have a couple bits of overlap between the two. And the overlap defines a window over which the timestamps can be reconstructed. So with 2 bits of overlap, you basically have 4 coarse timestamps that you can select between. And then in this case, the timestamp capture logic, in the max and all the PTP CDC logic, that would only handle the fine portion. So that goes from handling 96 bits, you drop that to 48 bits, you save a bunch of logic resources, save a bunch of block grams, and it potentially simplifies some of the timestamp math, because you don't need to go, okay, well, the fine bit rolled over, so now we need to increment the coarse bit if you need to offset something. So that simplifies a few things. And then the coarse portion, what we can do is transfer that using a relatively low speed clock. So I'm thinking something similar to SPI, maybe running at about a megahertz or so. You can easily send that, long distance across a device, and then synchronize that even into a much lower speed clock domain. And then what we can do is have the hardware clock shift out 2 coarse timestamps, basically the current one and then subsequent one. And then the reconstruction logic will store several timestamps in LUTRAM indexed based on these overlap bits. So whenever you need to reconstruct a timestamp, you just look at the values of the overlap bits, depict the coarse value, and reconstruct the full timestamp. So as long as you're not holding onto timestamps for longer than a second, then this should work, and it'll save a large amount of logic resources in the data path. So at some point in the near future, I think I'm going to start chipping away at this to see if it's, see how it's actually going to work from an implementation perspective. But it seems like this could be a pretty promising method for saving a lot of logic resources, especially when you have a lot of ports. 100 gig adding 96 bits per packet, well, 96 bits to the data width is not really a huge deal, but when you're talking about 10 gig or 25 gig and you're turning on a lot of ports, then this could be a big problem. So I think it's maybe going to be a bigger issue for, switch version of Corundum if we want to do PTP there versus, the NIC. But we'll see. I'm going to chip away at this and we'll see what it looks like. All right, and then the last thing for today is the team at Arista kindly provided an advanced sample of their 7132LB switch. I got one of them right here. It's an FPGA-based switch. They have a low latency design for it for HFT kind of applications. Inside, it's got a VU9P-3 speed grade FPGA. And on the front, it's got 48 SFP28s and 4 QSFP28s. So I've gotten the Verilog Ethernet design running on this thing. I've traced out all of the connections to all the front panel ports. And I have that up as an example design in the Ethernet repository right now. So it should be a good non-dev board target for the Switch project. It's one thing to get it running on one of the high-tech global boards, but this is actually a nice rack-mountable box. So the flip side, I honestly have no idea how much one of these things costs. So, that's the downside about some of this stuff. These are probably pretty pricey, but we'll see. The team at Arista has been pretty supportive. I don't know if anybody else is interested in the Switch project. Potentially, we can reach out to those guys. Yeah, I don't know if I have much else to say about this. That about wraps up what I have to talk about in terms of status updates for today. So if anyone has any questions or comments, fire away. Anyone have any questions or comments about anything? Anything that they want to discuss? About Corundum, project ideas, Switch project? No? All right. Well, I guess if we don't have anything to discuss, then I guess we can adjourn the meeting early. I don't know. I guess I should always ask the folks at the MLE, Joachim. Do you guys have anything you guys need to discuss? I know there's been some back and forth about the DPDK driver.
Yeah, right. Yeah, I'm currently thinking of if we really have a topic to discuss here. Yeah, perhaps this DPDK topic. I think we kind of solved it for the user who opened the issue.
Right. Yeah.
Obviously,
like trying to get it running, and I guess the solution is to use a specific revision of Corundum.
Yeah, that's the main problem.
Right.
The simple point is that we have had the time, and I think it's currently not on the horizon to move to the current version.
Right. Okay.
But it seems like that. Yeah, the user obviously wants to use the most current version, which is kind of natural, I think. But well, it is how it is currently. I'm sure we will come back to that, but I can't say when.
My thought is it probably won't be that hard to update the driver to operate with the latest version. It's just a matter of sitting down and making a few adjustments. But
right. Yeah, and our target actually was to take the kernel driver, your driver, and really try hard to keep everything as it is and just make changes where it is necessary. At least that should be the target, and then moving over should be kind of easy.
Right. So if you stick close to the original code, then it makes it a lot easier to backport updates and whatnot. Yeah, that makes sense.
The other issues, I think the other minor issues where we also kind of with your help solved them. Apparently there's something odd going on with Vivado and these vendor device ID settings.
Yeah.
Or glass code. It was the
So
glass code.
that's
Sorry.
one thing I was trying to figure out, because I went ahead and I rebuilt the I can't remember specifically which board they were using, but I rebuilt a couple of the Alveo designs, and well, I actually didn't build them completely, but I built it enough to get into Vivado and open up the configuration GUI, and it looks like it was showing all the correct settings. So
Mm-hmm.
I have not yet had a chance to try it with the latest version of Vivado. So it seems like it's possible there was some weird Vivado bug that's going on. It's possible though that the TCL script that I have is just doing something that Vivado is not expecting in some way. So the way that class
Yeah.
code is configured is kind of screwy, because there's kind of two ways of configuring it. They have this little assistant thing with a bunch of drop downs. You can select stuff, and then you can also just type it in. But in TCL, you have to either turn the configurator on or turn it off. And if you get that setting wrong, then even if you specify the actual value, it might ignore it. So I know that's a problem I had at one point, where I thought I had the class code selected everywhere, but it didn't apply correctly on most
Yeah.
boards.
We had all sorts of these problems in the past where Vivado, for some reason, overrode properties. And I think we had a case where Vivado overrode the property just before synthesis. So after generating the project, it wasn't obvious. I can't remember which IP core was the bad one, but I think there was such a case.
Yeah, that got me thinking that maybe what we need to do is see if there's a what we should do is open up the implemented design and see if there's a parameter or property or something attached to the PCIe, not the soft IP core, but the actual hard block that corresponds to the class code, and see if it's actually reporting the correct value there.
Okay. Yeah.
But one thing that I have noticed on this seems to only apply to ultra-scale devices, not ultra-scale plus. It seems to be somewhere along the line, the subsystem vendor ID is getting screwed up, and it just gets set to the vendor ID instead of whatever you put in there. So I don't know at what point that's getting screwed up, but it's not really a big deal, because that's only kind of informational. But yeah, I guess the other question, or the other thing I was kind of scratching my head over, is why the DPDK driver is looking at the class code at all, because for the kernel driver, it just ignores the class code. It's only looking at the
yeah, that's a good question.
Vendor and product IDs, or the vendor and device IDs. I'm not sure if DPDK has an option to ignore the class code, or maybe
to be honest, I didn't look into it,
okay.
So I can just speculate. My speculation would be that DPDK kind of thinks, okay, I want to match network cards only.
Right. Yeah, I mean, so that's possible. It's just my understanding is that you'll usually have like a list of devices to match. At least the way Linux works is you can kind of specify what fields you're interested in matching against.
Right.
So
yeah.
Vendor ID and product ID, and generally you either do vendor and device ID, or you do class code. You don't really do both.
Yeah.
Right? As a class code is kind of like for an NVMe, for example, would match class code.
Right. Yeah.
And I think maybe like USB controllers or something, but everything else is usually device ID and vendor ID.
Right.
But yeah, with Linux, you can kind of pick what you want to match. So it's possible for DPDK that there just isn't a way to say, just look at the device ID and vendor ID. Although it's possible there is a way, and just the driver you guys were looking at as a reference for the DPDK driver did match the class code.
Right. Most likely the last case, yes.
Yeah.
Just copy pasted a known good driver,
so
which does
could
it.
be a simple thing to do to fix that. It's like I guess it's one of these things where we kind of need to approach it from two directions. It's like, okay, one, we could fix the DPDK driver so it's not looking at that at all. which is probably a good thing to do. And then from the other approach, you go, okay, why is Vivado generating the wrong darn number?
Yeah.
And then between the two of those, it should fix the problem, hopefully.
Yeah. Yeah. So at some point in time, I will have a look into that in the driver code. But for now, I think the user should be able to, get somewhere. I hope. We had a little bit more of back and forth, and my colleague Björn posted his testing commands, and we'll see.
All right.
I'd say.
All right, that sounds good. Oh, Julian is asking about the DPTK stuff. Let me see. Do we have a URL for that? Let me see. There's probably something in. Let's see here.
Yeah, it's generally on GitHub, missing link electronics, and I think it's called then dptk-stable. Yeah.
Yes, I'm asking that because I found several projects on GitHub, and I didn't know which one was the most advanced.
Okay, yeah. So okay, there we
go. Good point.
Brian posted the link on the missing link electronics GitHub there, which is just they have a DPTK stable repo. I think we actually need to look at a couple of branches under that, maybe.
Right. Sorry. Yeah. It's the branches.
Kind of as an FYI,
called...
I've definitely run into that problem before.
Yeah,
I go to
you're
some
right.
repository, I'm like, it's supposed to be here somewhere. Oh, right, branches. Yeah. Well, I think you guys have a couple different branches under there for different versions.
Right.
Of
it's kind of a tricky situation there. We decided to provide the driver for multiple versions, for the stable trees of multiple versions. And currently we have the 20, 21, and 22 branches. So 3 branches, because we have the impression that most people use some stable version. So that was the decision to then apply it to such stable version and test against. But yeah, I'm not really sure how to move on from there, to be honest. I mean, the optimal solution would be to come up with kind of the 1.0 DPTK driver and then post it upstream and get it merged into the master. That would be the ideal solution, I guess. But for now, we had the impression that stable is used in terms of DPTK mostly, and that's why now we have 3 branches. And every time we need to update, we need to update it 3 times.
Yeah, and it will be worse in a few months when they will advance new branches, new stable branches.
You're right. Yeah, of course.
And the issue here is that the DPTK team is very tedious about the quality of code that they ask to be merged.
I hope so.
And I know that because I'm the maintainer of some board on it. So each time you do a patch, it gets under scrutiny, and it's sometimes difficult to merge something.
Yeah,
but
so
yes,
I guess
I agree with you that it would be the best solution. On the other hand, if the underlying FPGA stuff change, then it also cause issue on this, because we have to
So
code.
that last point is kind of the main reason I haven't been
Yeah.
like, hey, let's get an upstream driver, because there's
Mhm.
a lot of major changes that I have planned that are going to vastly, you know, change things in the driver. So, and I have no interest in supporting the, you know, old
DPTK.
version basically. So,
Of course,
once
logic.
those changes have been implemented and whatnot, then, you know, we can cut a 1.0 release of Corundum and look at getting upstreamed drivers and whatnot. But until then, I'm not doing any versioning because I'm not going to support the old version.
Right. So, and
Yeah.
the same would be kind of the statement for the DPTK part, I guess.
Right.
Before
Yeah.
1.0 doesn't make sense. So the other thing I was scratching my head about is it in the DBTK case, is it really needed to have it in tree to kind of do a fork here and or have branches? I mean, in terms of the kernel, we have the ability to build modules. So that's the way, Alex, you did that, just a repo with the module. Is that possible with DPTK 2 would be my question. And I think it should be possible. I mean, it's more or less like a user space dynamic loadable library. So if anybody knows that, I haven't
Yeah.
done
Well, so
research.
one real quick question. So you have driver code for 3 different versions of DPDK. How different are those? Are they almost identical, or is there a significant changes?
I'd say so. Almost identical,
Almost
yes.
yeah. Yeah, because I'm not sure the best way of handling something like that. I mean, I guess you could do like patch sets or something, and then you could have a, you know, download the repo and apply the patch and then build it sort of thing.
Yeah.
Which is not great, but I mean, I guess it would work.
Yeah, I guess then the better user experience is to just check out a forked repo.
Right.
At least from the
I
user's
guess,
point of view.
Well, right, but I guess there could be kind of a middle ground, right? Where if you do have some patches, then you could have kind of an automated way of applying those.
Yeah, yeah.
So basically, you can kind of regenerate your branches based
Yeah.
on the patch or something along those lines.
Right. Yeah.
Which still means that okay, you can just go ahead and clone this repository and build it without having to jump through any additional hoops.
Yeah.
I mean, I think it's like officially DPDK doesn't really support kind of out of tree drivers. That there isn't really.
No, not really. It doesn't. The logic is more like, you know, configure, make install, where you pass the different driver you want to build, and given the different dependencies you have on the libraries. For example, some driver like MLX 4 and 5 need a special support libraries in your system, and if you don't have them, then it doesn't compile them. It behaves like more like a program that you can compile with different options, and drivers are only options in a way of this program.
Right.
You cannot see the driver as some kind of shared library that you could compile externally from the DPDK. All the make file and all of that are not made for that. It would be possible in theory, but it's not made for that. And recently we had a question about this from the Open WRT guys who make a specific, router distribution that ask specifically that. And they were a little bit in dismay as well that it's one thing or nothing. So yeah, it's just it tends it comes from the way the DPDK has been synced at the very beginning of the project, and up to now it's still like this. And I agree, it's not very flexible.
I just remembered why I thought that should be possible. The point is, if we look at, for example, the Ubuntu or the Debian packages for DPDK, there's obviously a clear distinction. So the drivers are comprised in different packages. So they must be different files, different SO files, I guess. And the
Yep.
main point is the reason why I thought it should be possible. There's a dpdk-dev package, which is usually the name for a package which contains header files and so forth to build against. So that's why I thought, it might be possible. But if you say it is not, then my impression
I think what they do is that they compile everything, and then they build binary package, picking each stuff in it.
Right, but my point is, why do they have a dpdk-dev package then? If it's not possible to compile something against dpdk after packaging, then why have a dpdk-dev package? That's my reason.
Would that be for building applications that use DPDK?
Exactly. It's meant for you can use DPDK as a library after that.
Mm-hmm.
No, but that's
right.
my understanding.
Right. Yeah. Mm-hmm.
But that's an interesting point about packaging. I wonder how much of that automation is, available in somebody's repository somewhere, right? You might be able to see exactly how Ubuntu is doing the packaging for that.
Right. That's open source, yeah.
Just to see what they're doing. Because it's possible they just build DPDK normally and then make packages with a subset of the files.
Yeah, definitely. I mean, that's how packaging works for most things. I just missed the main point, Alex, what you said. Of course, we have to build applications against it. I completely forgot the application. Okay.
Well, actually, but that does raise another point that I was thinking of is with the modifications that you have in your GitHub repository, are those basically all contained to like a single directory, or do you have to modify several files?
No, it's nicely contained in a single directory. The directory structure is like in the Linux kernel, so there's drivers, net, and QNIC.
Gotcha. Okay.
That's straightforward.
Well, so it seems like you wouldn't necessarily even need to maintain a patch set per se, right? If you just have your DPDK driver as a folder, then that could just be pulled into the DPDK tree in the appropriate location, and then you just build it.
Yeah, right.
I don't know if you can do some sort of if-def type thing for the different versions for where there are differences that have to be taken into consideration.
If there are any version defines, then yes.
Well, right. So I don't know if there are version defines. That was, yeah. Because I know Linux has one, but I don't know. And Red Hat has additional ones,
Yeah.
But yeah, I don't know if DPDK has one. It'd also be just interesting poking around to see if anybody else has done something similar for DPDK. An out of Crete.
Right. Yeah. Absolutely. Yes.
It's entirely possible there's other projects that have done something similar. I guess another thing that's kind of weird about Corundum is that the hardware can change. Usually that's not the case. Usually it's like you have the hardware is fixed, and then you make a driver for it. But in this case, since both the hardware can change as well as the software, it's ends up being
actually it's not totally true, because now on the network card you have some kind of firmware, and the firmware can change a little bit the behavior on some part of the card.
Well, right, but I think there's a lot of stuff that's going to be pretty fixed, even though the firmware can change some things. So But
Yeah.
Yeah,
But for example, we have some issues having some newer driver with older firmware, and in this case, we have some curious bugs, and sometimes it just doesn't load
oh, interesting.
because
Which
the firmware
card?
is too old. Sorry?
Which card?
Oh, I've seen that with Intel cards and with the card I maintain, which is a Broadcom one.
Okay. Interesting.
So yeah, sometimes it's some kind of details, you know, the size of something somewhere, and then some check just doesn't work. But yeah,
mm. Yeah, well,
Another thing you could do is just say you got to update the firmware. But
yeah,
I guess it's not something totally new. I mean,
yeah,
in the past, the first Wi-Fi devices, I guess, the Wi-Fi devices started this neat firmware thing. At least the cheap ones always needed a firmware back, I don't know, 15 years ago. So it's not totally new to depend on a firmware.
Well, I guess it's a different story between requiring firmware to be loaded onto the device versus, having different versions of the firmware that vastly change the interface.
Yeah.
And that's
True.
definitely something to watch out for with drivers where you have to do stuff with the high performance, because, if you have to do some firmware version dependent, branching somewhere, you got to be careful how you do that so you don't murder the performance.
I guess all in all, that kind of even if MQNIC is at 1.0, then I mean it's still true that, well, the hardware, meaning FPGA design, can change. So basically the situation is the same, and I guess one has to see how such upstream projects like Linux or DPTK deal with that, or are willing to deal with that, to have a driver which potentially does not match a certain hardware. But I think in the end we have those register blocks with unique versions and identifiers for that.
Right. So there's a couple things I was thinking about here. So one of them is it might actually just make sense to start up an email thread with some of the DPTK people and just ask what should be the procedure for dealing with that, right? Is this something that is never going to be allowed into DPTK because of this, or is there a mechanism for handling that, or what? That might be something just to get their opinions on and just get it on their radar as a possibility. It's possible they're already thinking about it, then they could point us at some sort of resources along those lines. Another thing that I was thinking about is, with some of the reorganizing that I've been thinking about in the register space and whatnot, and also with the little management CPU, well, maybe it makes sense to even consider having another kind of layer of indirection, if you will, where instead of the host directly accessing a lot of the registers, it would basically write out some sort of a request, and then maybe the management software, maybe another software would process that request and perform the necessary updates to the internal registers. And then this could potentially loosen up the versioning a little bit, because you could potentially have several different API versions that this little software could support, and then the driver and the software can negotiate on a common API version. And obviously this would only be done for all the setup and teardown type stuff.
Otherwise performance
data path. But that could potentially alleviate some of these issues. I mean, obviously if you're doing application specific stuff, then that's a different story, but I think the idea is that that's kind of separate from just the NIC data path, and that the NIC data path should end up getting more stable at some point, once some of the core features get a bit more fleshed out. So I don't think the stability in terms of how the internal design changes is going to be a huge problem, going forward after a certain point.
I mean, in the end, perhaps we have to, look at it in another way and say, well, there's MQNIC 1.0, and that's the driver for it. And it has a certain stability in there, no major changes. And if there are major changes, well, then there is another MQNIC flavor there with a separate driver, potentially with in software in the kernel a little library, which a support library supporting both, or at some point only one. I mean, that's how, I guess, how the NIC vendors do it. I mean, they make one NIC and then they make the next version. And if you look at the code in the Linux kernel, well, some drivers support multiple NICs, which have been added over time. So perhaps that's the way how to view it.
Right. I guess the only difference there is that, with an FPGA you can load whatever image you want, versus with those NICs, once they've spun their chip, they can't really change it. And if they make more of them, they can't update it to use the new design.
Right.
They spin a new chip. So the FPGA can always just say, okay, just update to the latest HDL, and then you have all the new features and you're using the latest driver and whatnot. So I don't know. Definitely something that's going to require some more thought, I think. Anyway.
And we ask for the DPDK what you just said. How does it work? With changing version, like you said. You just told that we have to see how they handle. If I understood correctly, we have to ask something to the DPDK community.
Right. Yeah. So I was kind of thinking in terms of a lot of the hardware they currently support now, I think is pretty static, right? Because it's all, custom silicon, and all of the functionality is silicon. It doesn't really change. But if they have a target where it's going to be changing over time, right? Where Corundum, we're going to be, making changes to the low-level interface and whatnot. How would that be handled at the, DPDK project level, if we would have to be updating that driver on a pretty short time scale, potentially, just so that it works, period, not just improvements, but
I wonder how they do, because
potentially with some of the newer networking hardware, right? Like some of the smart NIC type devices could potentially be similar moving targets. Although at the same time, it's possible that the networking side of it that DPDK interfaces with directly maybe doesn't change, even though other application specific stuff can change.
Maybe on the PCI layer there is some kind of field with a version or something that we can use as a version, to say, okay, from the driver we can read that, and then that this, if it's version 1, for example, it's the current hardware access, and if it's version 2, then you can use a newer API, something like this.
We have all of
and so you have one driver that handle both types and many types on the long run. That's one way to see it.
Yeah, so in the register layout for Corundum, it's built up in these register blocks, and each register block has a version. So if that bit of functionality gets updated, then that version gets bumped.
That's how it works currently with the card I maintain. You read the firmware version, and based on this, you can do some, with some defines and all of that, you can adapt a little bit how the driver works when there is changes, a little bit of change. So I think we can use the same mechanism. That's one way.
Right. Yeah.
I don't know if it
The point
it's
is that we
just
can
a
absolutely
possibility.
do that. It's just with it's just the driver is only going to know how to talk to hardware that's, it was developed for, right? So if you have an upstream version of the driver in DPDK and then a new version of the hardware is released with new version numbers, then the driver's not going to know how to talk to it, right? Because it's going to go, oh, I don't know that version number. I can't talk to this device.
Sure.
So that's a potentially problematic situation. So that's why I'm thinking that, maybe, kind of abstracting away a lot of the control registers a bit could potentially help, because then you can reorganize the control registers without having to worry about the software facing API. And you could potentially support, multiple versions or multiple variations of the various commands in a potentially backwards compatible way, right? In such a way that, a new version of the driver can talk to old hardware, and the old version of the driver can talk to new hardware. Obviously, maybe won't be able to utilize all of the features, but it should at least work. But yeah, this is something I haven't really put a whole lot of thought into. It's just like, well, that might be something to consider, because there might be some significant advantages to doing that. And it seems like there's a fair number of drivers that do something similar. Like I've taken a look at, I think both the Mellanox driver, and I think I was also taking a look at maybe it was a fungible device as well. They all seem to use a similar technique where they have a command queue sort of thing that gets allocated, and then when you want to create a TXQ or an RXQ, you basically create a little data structure that gets written into the command queue, and then you get a response back from the card. So they're not doing register reads and writes. Obviously, you need those for doorbell registers and whatnot, but basically the way you can do that is, whatever entity is running on the card can just say, hey, use this address for the doorbell. Then you can rearrange things however you need on the hardware side in terms of the register space, and as long as it's telling the software to do the right thing, then everything works. So
it's kind of in Unix, everything is a file, everything is a queue.
pretty much, yeah.
Well, what I wanted to add in terms of the versioning, the current version scheme would allow to say, well, let's use that semantic versioning scheme, and on updates, update versions accordingly. So a driver could not just compare against a certain version, how it's currently in the driver, but compare against smaller than this version.
Yeah, I have been thinking about, something like that might make sense. Yeah, we definitely could do something like that. And then, yeah, if you're going to have stuff that's causes compatibility issues, then you bump the appropriate version number to make that work. Yeah, that absolutely would be possible. But I was just thinking that if we do bring in an additional software or something that that handles these messages, then that might simplify things in terms of better supporting backwards compatibility, because you run into the same issue even with doing kind of a semantic versioning, where yeah, you can have a little bit more compatibility, but still, if you do bump the major version number, then the older version of the driver won't be able to talk to it. So, but if you have a little software that can handle potentially older versions of some of the commands, then maybe it would work. I don't know. That's something I need to mull over a little bit. And I was also thinking it probably makes sense to have a separate soft core for that, such that all of the boards can run the same firmware for that core. So basically, we have two cores: one the board management core, and the other one the data path management core. So the board management core runs board specific firmware. Data path management one, all the targets run the exact same firmware. Just to simplify things.
Okay.
I don't know. Something I've been doing a little mulling over because it could possibly make some of the versioning easier. Anyway, do we have anything else to discuss? Or I think that pretty much, I don't have anything else I want to bring up necessarily, but
It's fine.
that's fine. All right. Well, I guess
Yep.
We can adjourn the meeting for today, and we'll see everybody in 2 weeks, or in 1 week if you want to talk about the Switch. All right. Well, thanks
All
for
right.
tuning in.
Bye-bye.
I'll talk to you guys later.
You.
Yeah.
Bye. Thank you.
Thanks. Bye.